Hello, good evening all of you. Audio video clear, please mention. Welcome all of you to this lecture. Today's topic is reminder theorem or reminders. All clear? Yesterday's lecture there was a small audio issue. Today it is sorted, I guess. Please let me know whether the audio video is perfect. Okay, so let's start. Let me know whether the audio video is perfect. Okay. Okay, so let's start. Reminders. In the last chapter, we discussed about LCM HCF. Before that, divisibility was also discussed. The idea of divisibility, all of you are clear about, I guess. So that idea of divisibility is needed here also. We'll discuss that. For the new students, this is a course where we are discussing all topics of UPSC CSAT in 30 minutes. Like every lecture, 30 minutes it will be the time duration, and it is useful for other exams also, CSIR NET, GATE and other exams also. So it's a common lecture for other competitive exams also. So if you want to invite your friends who are preparing for other aptitude test also, it will be useful for them. But the UPSC syllabus, all the topics will be covered in this course. Other exams, maybe few topics will be missing from this course, but UPSC, all topics will be covered of the quantitative aptitude and reasoning section. For the new people, my name is Christy Varghese. These are the books I have written for general aptitude and Vedic maths, and the flashcards and the courses I publish is available in the mobile application Christy's classes. Check the description of the video to find the link of this, and if you want more free study materials, you can be part of our Telegram channel, WhatsApp group, mobile application and our website christyvarghese.in. Check the description of the video or scan this QR code to be part of these free resources. And in this YouTube channel you can find many playlists. For UPSC there is a separate playlist, for CSIR NET, for GATE and other exams also there are separate playlists. Those of you want to check out can check it out. And this is the structure of this course. We are discussing today reminder theorem or reminders, 6th lecture in this course. Those of you missed the previous lectures, subscribe the channel and check out the previous videos in this channel, where you can find all the previous 5 videos in this course. Okay, so let us start. Reminder theorem starts from division algorithm. What is division algorithm? We discussed this in divisibility chapter also, but if any of you have missed that chapter, I will just summarize it once again. Dividend is equal to divisor into quotient plus remainder. For example, 60 is equal to 10 into 6 plus 0. 60 mangoes, if you are trying to divide among 10 people, everyone will get how many mangoes? Everyone will get 6 mangoes. Now 10 people, 6 mangoes each. So that is 10 into 6. No remainder. There is nothing remaining after dividing 60 mangoes among 10 people. So that is why no remainder. So that is why what you are dividing with, that is the divisor, and how much you are getting. When you are dividing, everyone will get how much. Like in the example of mango dividing among people, every person is getting 6 mango each. That is called the quotient. And if is there any mangoes remaining after this division done, that is called remainder. In the case of 60, there is no remainder. In divisibility chapter, we were discussing about this situation, when there is no remainder. In this chapter, we are discussing about when there is remainder, how to deal with it. For example, if you have 62 mangoes and you have 10 people to divide it among. If everyone we are giving mangoes, first we will give 1 mango to everyone. So 10 mango completed. 1 more mango to everyone, 20 mango completed. 1 more mango to everyone, 30 mango completed. Likewise, 60 mango to be completed, you need to give 6 mango each for 10 people. But after that there are 2 mango remaining. That is called remainder. Again, this is very basic, but the problem is many people get confused. Divisor, is it divisor or dividend? Confusion between divisor and dividend. Confusion between where, when you will get remainder. So those confusion you can avoid if you understand it in a practical way. Like number of chocolates divided among some students. So practical examples you take, it will be very easy. And if you do that, this theory we are going to discuss will also be very easy. In this chapter, this theory, when you are dealing with reminders, how to deal with it is very important. For example, when you have a number and you are dividing it with another number, the remainder obtained can also be thought like, if you are expressing that number as a sum, each of the number divided by that n, that remainder is added. If that is complicated to understand, take this example and see. 26 plus 40 plus 16 divided by 13. What is the remainder? You can separately find the remainder of 26 by 13, that is 0, because 26 mango divided among 13 people. Is there anything remaining? In this chapter, we don't want quotient at all. We want only remaining. So 26 divided among 13 people, there is no remainder. So 0 remaining or 0 remainder. 40 divided among 13 people, 1 remaining. 16 by 13. 13 by 13 is exactly divisible. Remaining 3 is remainder. Na? So 0, 1 and 3 are the respective remainders. Adding those remainder, you will get the final remainder. All of you are understanding? So 26, 40, 16, if you add, what you will be getting? 26 plus 40, 50, 66 plus 16, 82. Remainder of 82 divided by 13, you check. 78 by 13, 78 is a multiple of 13. So 82 by 13 gives you remainder 4. Na? So 82 by 13 also, if you want, you can break it down into smaller numbers that you know the remainder of. And then adding the remainder is easier. Na? All of you are understanding this idea? Then I will show you a few questions. You tell me the answer of this. What is the answer of this? Super fast answer this, please. All of you who are watching me live, please answer it. Those of you are watching me recorded also, you can comment on the comment section if you are getting an answer. So 140 divided by 13, due to lack of time I will start explaining. 130 divided by 13 was exactly divisible now. Plus 10 divided by 13, you can write like this. That is what we just discussed, because 140 is 130 plus 10. So 140 by 13 is same as 140 plus 10 by 13. 140 plus 10 by 13. So 130 by 13, 0 remainder. 10 by 13, 10 remainder. 10 mangoes divided among 13 people. You cannot divide it now, because there is no 13 mango. Minimum 13 mangoes are needed to divide among 13 people now. Otherwise, no one will get even 1 mango each. So all 10 are remaining. Quotient 0, remainder 10. So 0 plus 10, 10 is the answer. All clear now? So that is the application of this idea. There was many previous year question based on this idea itself. I will come to that. First we will practice few examples, simple example, and then we will go to the PYQs. So please try this super fast. 1, 2, 3, 4, 5 is divided by 4. This is connected to the divisibility or test of divisibility idea also, which we discussed in the last lecture. Please try it and answer it super fast. After trying this, you try 1, 2, 3, 4, 5 divided by 8 also. Divided by 4, divided by 8, both please try. I'll get some water and come. Please complete this questions, 2 questions. Most of you got an answer. Very good. So test of divisibility of 4 is what? Last 2 digits being multiple of 4, number is a multiple of 4. 2056, 56 is a multiple of 4, so 2056 also is a multiple of 4. So 1, 2, 3, 4, 5, that is regarding multiplicity, na? But that idea can be extended here. Last two digits that determine multiplicity of 4 na. So if it was 1, 2, 3, 4, 4, that is divisible by 4 because 44 is divisible by 4. So 1, 2, 3, 4, 4 is divisible by 4 means 1, 2, 3, 1, 2, 3. 1, 2, 3, 4, 4 mangoes divided among 4 people. Everyone will get equal number of mangoes, no remainder. So 1, 2, 3, 4, 4 plus 1 is 1, 2, 3, 4, 5 na. So this remainder is 0, so this remainder will be 1. 0 plus 1, 1. Very easy na. Yeah, this theorem is very simple theorem itself. When it is written in a mathematical form, it looks very like clumsy. But once you understand the logic, it is super easy and super convenient to do questions with this. So 1, 2, 3, 4, 5 divided by 8. What is the answer then? 1, 2, 3, 4, 5 divided by 8. 8's divisibility we discussed already. Last 3 digit multiple of 8 number is a multiple of 8. 056 multiple of 8, so 2056 is a multiple of 8. So last 3 digit 345. There also try to break down numbers, then it is easy. When you see 345, you may not get any idea what is the nearest number multiple of 8. There you have to break it down. I think I have told it in the LCM HCF chapter also. If it was 80 mango divided among 8 people, no remainder na. 160 mango also, no remainder. 240 mango also, no remainder. 320 mango also, no remainder. Till 320 you reach. Now 345 is easy na. 320, 328, 336, 340, 44. So we understood that 344 is a multiple of 8, or 1, 2, 3, 4, 4 is multiple of 8. So 1, 2, 3, 4, 5 is 1 more than a multiple of 8. 1 more than a multiple of 8 means remainder will be 1. So for this also the answer is 1 itself. All clear? Please respond all of you. Is this clear or not? Then what about this 1, 2, 3, 4 divided by 5? Due to lack of time I will start explaining. You can answer in the chat. It is easy only. Test of divisibility of 5 will help you here. Last digit being 0 or 5 is enough na. Last digit 0 or 5 means 1, 2, 3, 0 is the number below 1, 2, 3, 4 which is divisible by 5 na, because it is ending in 0 plus 4. So this remainder is 0, so this remainder is 4. 0 plus 4, 4 itself is the answer. Super easy na. But in this case 1, 2, 3, 5 is multiple of 5. So 1, 2, 3, 5 plus 3 is 1, 2, 3, 8. So 3 is the remainder because this remainder is 0. 0 plus 3, 3. Super easy. If it is 25 also you can do this, because if you observe 25, you cannot just by heart too many rules. Sometimes or many a times some basic rules you understand, later you have to extend that idea further. 25's multiples, think about 25's multiple, 25, 50, 75, 100, 125, 150, etc. This 25 ending, 50 ending, 75 ending, 00 ending, 25 ending, 50 ending. This pattern will repeat, 25, 50, 75, 00. Shanti, which part can you specify, which question you have doubt on? Because if you have doubt, please specify, then it will be easy, because this is a half an hour session. Lesser time, more content delivery, that is the objective of this. So I also will go a little faster. So if you pinpoint the doubt, definitely I am ready to answer. Short session does not mean doubt should not be cleared. You are free to ask your doubts, but specify which part. Okay, so anyway, that means 1, 2, 3, 1, 2, 2, 5 will be multiple of 25 na. 1, 2, 0, 0 is multiple of 25. 1, 2, 2, 5 also is multiple of 25. 1, 2, 2, 5 plus 13 is 1, 2, 3, 8 na. This remainder is 0, this remainder is 13. 0 plus 13, 13. 13 is the answer. Super easy. All clear? What about 9? 9's divisibility is based on sum of digits na. Sum of digits. If sum of digits is a multiple of 9, number is also a multiple of 9. 1, 2, 3, 8. 1 plus 2 plus 3 plus 8. Let us check that first. 3 plus 3, 6. 6 plus 8, 14. 14 is not a multiple of 9. But instead of 8, if you are replacing 14 minus 5 is 9 na? That means 5 digit less. If it was 1, 2, 3, 3, just check that. 1, 2, 3, 3 divided by 9 is divisible na? 1, 2, 3, 3. Why? Because 1 plus 2, 3. 3 plus 3, 6. 6 plus 3, 9. 9 is divisible by 9. If sum of digits is divisible by 9, number is divisible by 9. We discussed that already. Test of divisibility of 9. So 1, 2, 3, 3 is divisible by 9. So 1, 2, 3, 3 plus 5 is 1, 2, 3, 8. Hello. I think it is audible. So let's continue. Yeah, there was some network issues. So let us continue. Is it clear now? Please respond. Okay, so yes, so let's continue. Sorry for the delay. For subtraction also you can use the same idea. That is what I was telling. I think till then all of you were able to hear now. Okay, so let's continue. So 30, 57, 22 difference division by 11. So 30 by 11 is what? 22 by 11 is pseudo remainder. So 30 by 11 is 22 plus 8 is 30. That idea should come. 11 mango divided among 11 people, possible, no remainder. 22 mango divided among 11 people, possible, no remainder. 22 plus 8 is 30, so 8 is the remainder. It should come in your mind. As I told, you are not in school now, so you cannot write all the division steps and all for that. 30 by 11, you cannot divide it and find the remainder. You have to get in your mind 11, 22, 33. That are the multiples of 11. That idea will help you to do this. So anyway, 8 you will get. 57 by 11. 55 divided by 11, remainder is 2. Sorry, remainder is 0. So 57 is 2 remainder. 22 by 11, 0 remainder. So that subtraction will give you remainder, final remainder. So that is the idea of subtraction. In this case, for example, yeah, I will show you more PYQs now, otherwise time won't be enough. The same true for multiplication also. 13 into 38 into 49 divided by 12. 13 by 12, remainder 1. 38 by 12, remainder 2, because 36 is divisible by 12. 49 by 12, remainder 1. So 1 into 2 into 1, 2 is the final answer. Super easy, na? Instead of multiplying this big numbers, you just have to find separately the remainders. So that also examples you can see here. 13, 38 divided by 12. 1 remainder, 2 remainders. So 1 into 2 is the final answer. 7, 14. 14 plus 4. 97 is 6 remainder. Check it out yourself later. 4 into 6 into 1. 4 into 6 into 1 is 24. But 24 cannot be the remainder when you divide by 7. When you divide by 7, the remainders can only be 0 or 1 or 2 or 3 or 5 or 6. It cannot be more than 7. 7 or more than 7 is impossible. So when you get 24, you have to again divide by 7. That is the idea. When you are getting number more than 7, when you are dividing by 7, you have to again divide. Not only for 7, for any number that is the case. So 24 by 7 remainder is 3. So 3 will be the final answer. All clear? So due to lack of time, I will just go to the next concept. Negative remainder. Negative remainder concept is very convenient. In calendar problem chapter also this is very important. We will discuss calendar problem. That time I will discuss more about it. For example, when you are dividing 49 by 10, the positive remainder is 9. All of you know now. 49 mangoes divided among 10 people. 49 mangoes divided among 10 people. Everyone will get 4 mangoes each. What is remaining is 9 mangoes. That is a remainder, or that is the positive remainder. But there is something called negative remainder. With respect to the mango example, if I tell 49 mangoes when I am trying to divide among 10 people, I will think like first I gave all of them 1 mango. Then 1 more mango, so 2 mangoes now. Then 1 more mango, 3 mangoes now. Then 1 more mango, 4 mangoes now. After that I am thinking, I have 9 more mangoes. Now I am not able to give everyone because one person will not get a mango. So there I am thinking in an optimistic way. If there was 1 more mango with me, I could have divided it completely now. If I have 1 more mango with me. But I don't have that 1 more mango. That means that is an imaginary mango. Or -1 is the remainder, we can say in this case. Or in other words, to understand this I will tell you, 49 is 40 plus 9. Na? Or this 9 extra is the thing that you should remove to make it a multiple of 10. That is the meaning. Na? Same way, 49 can be written as 50 plus -1, so that this -1 is the number to be added to make 49 a multiple of 10 to exactly divide it. This is the concept of negative remainder. Negative remainder. All of you understood negative remainder. One more example. 33 divided by 5. 33 by 5, 30 by 5 is exactly divisible. So 33 by 5, remainder is 3. Remainder is 3. But I can think it like, if 2 more mangoes were there, I could have exactly divided now. Remainder would have been 0. To make the remainder 0, what extra added? That is the negative remainder. So the negative remainder is -2. All of you clear about this? I will tell you why this is relevant. With the example of calendar, I will briefly mention it. Yesterday I showed you a question in LCM HCF chapter where calendar was involved. Na? This number system is the base of everything else in quantitative aptitude and in some chapters of reasoning also. For example, in calendar problem there is a concept called odd days. For example, today when I am discussing this live or discussing this concept in the live lecture, today it is 17th April, that is a Wednesday. If today is a Wednesday, 7th day is a Wednesday, na? Because 7 days in a week. So 7th day from today is a Wednesday, 14th day is a Wednesday, 21st day is a Wednesday, 28th day is a Wednesday. Multiples of 7 will be Wednesday itself. That means if you want to find the 30th day, what I will do? I will find the remainder when I divide it by 7. Na? Divide what? Divide 30 by 7. So 30 by 7 I am taking the remainder itself. This is one practical example of why remainder theorem is important. Because 30 by 7 is 28 by 7 plus 2 by 7. Na? 28 by 7 give you 0 remainder. So 30 by 7 give you 2 remainder. That means Wednesday 2 days shifted, it will be Friday. The 30th day will be a Friday. All of you are understanding this, please respond. So if I am saying what will be the 69th day, can you tell me? If today is a Wednesday, 69th day from today will be what day of the week? What day of the week? Can you tell me? Due to lack of time, I will explain. You tell your answer in the live chat. I can think it in two ways. I can think it like 63rd day will be a multiple of 7. So that will be again Wednesday, because 7 days it will be again same day repeated. 63rd plus 6. So remainder 6 means 6 day added to Wednesday. Wednesday 6 day added will be Thursday, Friday, Saturday, Sunday, Monday, Tuesday. Tuesday will it be. But that is time consuming now. Instead, if you use the negative remainder concept, I can think it like I only have 69 day, but what if one more day was there and it is 70th day? 70 is a multiple of 7 na? So that is a Wednesday. If 70th is Wednesday, hypothetically we are assuming it, then 69th will be 1 day before na? 1 day before means negative remainder is what we are using. Now you understood the relevance of negative remainder. Many a things when you we understand the relevance, it will be very easy. So negative remainder is very convenient. That is why we are introducing this negative remainder. In school we don't discuss about negative remainder, we discuss about positive remainder only. But if question is asked like this, 46 into 45 divided by 47, what is a remainder? Here negative remainder will help you. Why? We discussed that 46 into 45 divided by 47 is 46 by 7 remainder you take 46 by 47 remainder you take, 45 by 47 remainder you take, then multiply it. But 46 by 47 remainder is 46 itself. 45 by 47 remainder is 45 itself. That means it is equally difficult as multiplying the original sum, because it is the original sum itself you are getting as the remainder, original product, sorry. That is why positive remainder is very time consuming to solve this question, because you have to literally multiply it. But if you think 46 is 1 less than 47, so minus 1 is the negative remainder. Similarly here it is minus 2. Minus 1 into minus 2 is plus 2 na? That will be the answer. Super easy na? If you don't believe me, take your calculator and multiply 46 into 45. And that product you divide by 47 and see what is the remainder you are getting. It will be 2. So that is how negative remainder is helpful. So try these questions yourself. Today's topic is little time consuming. I have to start PYQ, so we will go a little faster. Now what about powers? What about powers? That we will discuss now. Remainder of ax plus 1 raised to n divided by a is 1. Again, looking at this, this looks tricky. But look at this example. 33 raised to 345. First of all, exponent means what? Repeated multiplication. Repeated addition is multiplication. Repeated multiplication is exponents. 33 raised to 345 is 33 into 33 into 33 into 33, 345 times now. Each 33 by 8 gives you remainder 1. That we discussed already now. 32 by 8 gives you remainder 1. So remainder 0. So 33 by 8 gives you remainder 1. So all are 1 itself. 1 multiplied 345 times will be 1 only now. That is why this is 1. Dividing by A, that A's multiple plus 1. 33 is 8's multiple plus 1. But 31 is 8's multiple minus 1. 32 minus 1. 32 is multiple of 8. Okay, please respond one thing. Are you all following? I'm going a little faster. Those of you are not able to follow, pause the video and you can go back when you can play back also, replay it so that you can understand it. The time constraint is there. After this, some of you have to attend the next lecture also. That is why I'm not delaying. But please give feedbacks, that will help a lot. And definitely, if you are feeling the lecture is useful, please hit the like button. That will help this video to reach more and more people. Definitely, I want more people to see this video, more people to be part of this initiative. So please support this initiative. Your like button, hitting the like button itself, YouTube will know that this session is worth sharing. Okay, so coming back to, so 31 raised to 345 is 32 by 8 is divisible by 8. So 31 by 8 is divisible by 8 minus 1. So minus 1 is the remainder. 31 raised to 345 is 31 into 31 into 31 into 345 times now. Each 31 is 1 less than a multiple of 32. So minus 1 is the remainder. Minus 1 multiplied 345 times. That is where odd and even power will come into play. Because minus 1 multiplied, for example, minus 1 3 times if you are multiplying. Minus 1 into minus 1 into minus 1. Minus into minus plus, plus into minus minus. So it is minus 1. But minus 1 4 times if you are multiplying. Minus 1 into minus 1 into minus 1 into minus 1. Minus minus plus, minus minus plus, plus plus, plus 1. That is why if it is odd times multiplied, it is odd or minus 1. If it is even times multiplied, it will be plus 1 itself. So 31 raised to 345 by 8 is minus 1. 31 raised to 346 by 8 is plus 1. Because 345 is odd, 346 is even. Is it clear, all of you? Finally, when you are trying to find the remainder of expression like x by y, if you can take out a common factor out of it, you can cancel the common factor. That is what this rule says. For example, 80 by 12 remainder. Instead of dividing 80 by 12, you can cancel the common factor just like you do in division. Like if you want to divide 120 by 40, first you will cancel the 10, then you will cancel the common 4. Na? Same way, you can see a common 4 here in 80 and 12. Take the common 4 outside. Take that common 4 outside, you don't cancel here. In dividing, you will cancel it na? Because it is there in the numerator and denominator. But in the case of remainders, you have to take it out and finally you have to multiply the remaining remainder multiplied by that common factor. So 80 by 12 if you normally divide also, 12, I am taking simple example to make you understand the concept. 80 by 12 you can normally itself divide and see, because 12 is multiple. 60 is a multiple of 12. 72 is a multiple of 12. 72 plus 8 is 80. So 8 will be the answer. But if you do the common factor thing, if you take out the common 4, 4 is outside. Don't cancel 4. You are taking out 4. Remaining is 20 by 3. That is easy to find 20 by 3 because 18 is a multiple of 3. 20 is 2 more than a multiple of 3. So 2 is the remainder here. 4 into 2, 8 is the answer. All of you are getting this? So this many rules you have to know about remainder theorem or remainders. Now let us see practical question. All question you don't have to use all the rules, but directly or indirectly you are using these rules. Let us take 2 latest question paper questions so that you will get convinced how this chapter can be easily solved. Please try it super fast. 30 seconds I will give you. I know 30 seconds is very less time, but we have a time constraint here. Hope I'm not going too fast. I'm speaking a little faster to adjust the time. That if you want, you can put on 0.75x or something if it is totally fast to follow. But it is audible and it is understandable, I guess. Danuj, this course will be definitely useful for CSIR NET 2024 also, because these topics are there in CSIR NET also, but some extra topics are there for CSIR NET, and some extra type of questions of some chapters are also there. So that you can check out in the mobile application Christy's classes, Danuj. In mobile application Christy's classes, there is a dedicated course itself for CSIR NET General Aptitude also. Okay, so due to lack of time, I will start explaining. Reminder, when 85 into 87 into 89 into 95 is divided by 100. So you know that this is a product. So each number divided by 100, multiplying that reminders is enough. That is what we just discussed. But each number divided by 100 also, each of the number are below 100. So that will not help you, na? That is where here options are more helpful. Options are more helpful. How? If you look at, I told you earlier about this 25's multiple. Now 25's multiple is 25, 50, 75, 100, 125. That question we discussed. Now same way 100's multiple are all ending in 0, 0. Now 300, 400, 1500, 10,000, 20,000, 20,500. All are 100's multiple. So if the number is ending with 0, 0, it is divisible by 100. It is divisible by 100 means no remainder. No remainder, na? So if you look at this, you can take a 5 out of this. When we discuss LCM, HCF, we discussed about prime factorization. Na? Either you prime factorize or look at the numbers and say, there is a 5 anyway in this because this is 5 ending number, so 5 is there. 5 into something is this. Here also there is a 5. Here there is a 2 or there is a 4. 96, 80 is a multiple of 4. So 84, 88, 92, 96 all are multiples of 4. You are anyway going to multiply all this, na? So 5 into 5 into 4 multiplied, you will get 100, na? 100 means this number is 100 into something. That's something we don't have to worry about at all. This number ends in 100 only. This number ends in 0, 0 only. A 0, 0 ending number divided by 100, remainder will be 0, 0 only. So option A is the answer. Super easy. All of you understood this? Establishing that this number is 0, 0 ending, that was enough to finish this question. According to the merit of the question, you have to deal the question. Yeah, just like in a Malayalam movie it is mentioned. For the Malayalis here, I am telling that for a rat we will not use AK-47. Now for the rat you will use a poison. Just like that, for this question, using the idea of the last 2 digits being 0 is enough. You don't have to find the product, or you don't have to find any other, you don't have to use any other properties of reminders to do this question. Here the idea of 85, 5 is a multiple of 85 is a multiple of 5, 95 is a multiple of 5, 96 is a multiple of 4. So when you prime factorize, this product will have 5 and 5 and 4 in it. So 5 into 5 into 4 is 100. So this is 100 into something. 100 into something ends in 0, 0. Na? 100 into something will end in 0, 0 only. Just look at all 0, 0 ending number. 1, 2, 3, 4, 0, 0. Divided by 100. What will be the remainder? As this is a multiple of 100, remainder will be 0. 1, 2, 3, 4, 0, 0 mangoes divided among 100 people. Everyone will get equal number of mangoes. No remainder. What is the remainder? No remainder. 0 remainder. That is the answer. Is it clear? Okay. I have repeated once more. Is it clear now? If there is a doubt, please specify the doubt now. I will explain that part in detail. This is a product, or if you are not at all understanding, go back to this principle itself. I told you when you split a number into smaller products and dividing it, that will work, we discussed now. And we understood that you can split 85 into 5 into something. That 5 and the 5 from here and the 4 from here, if you want I can combine it again. Now I can combine it again, 5 into 5 into 4. If you take 5 by 100 remainder, 5 by 100 remainder, 4 by 100 remainder and multiply it. Or if you multiply and take the remainder, the result is same. That is what this rule is saying. That is the meaning of this rule. That is why we are multiplying that, and we are understanding that this remainder is going to be 0. This remainder is going to be 0. That 0 remainder into whatever other remainder will be 0 remainder. Now that way you understand if you are not getting the idea. Some of you are why not taking 87 and 89? Because 87 and 89 is not that what we need to solve the answer faster. Again, the priority is to solve the question faster. Na? Some of the question it is prerequisite. Some of the question it is not necessary. This was a latest CSAT question asked in 2023. That is why I am explaining this in detail. Hope it is clear. Please respond. The same idea was asked in 2020 also. Try this as homework. You can do this in different ways. I told the easiest way now. Now one more question in 2023. Those of you who have doubt in previous question, can you specify the doubt? I will give you a simple example to make you understand. 5 into 4 into 5 into 6 into, 5 into 4 into 5 into 6. This divided by 100, what is the remainder? What do you think? 5 into 4, 20, 20 into 5, 100, 100 into 6, 600. 600 by 100 remainder is 0. All of you are agreeing, na? Or in I can say that 600 is 6 into 100 divided by 100. And by the rule we just discussed now, this is 6 by 100's remainder into 100 by 100's remainder. 100 by 100's remainder is 0, na? 100 by 100 remainder is 0. 0 into 6 by 100 remainder is 0 itself. Same thing we used here. This was a simple example, but this was a complicated example. Here we need to take out those convenient numbers which gives you 100 as the product. That's all. Clear now? Then try this question. Due to lack of time, I will start explaining. What is the remainder if 2 raised to 192 is divided by 6? 2 raised to 192. One idea we use in the next, we learn in the next chapter. Surds and exponents idea also will be used here. But I will explain it as much logical as possible. 2 raised to 192 means 2 into 2 into 2 into 2 into 2, 192 times. Nah? Each 2 into 2 gives a 4. Each 2 into 2 gives a 4. So 4 into 4 into 4, 96 times. Or you can use laws of exponents. That is what I told. In surds and exponents we will be discussing that. 2 raised to 192 can be written as 4 raised to half. 2 is 4 raised to half. Nah? Raised to 192. If you multiply that also you will get 4 raised to 96, half into 192. Or just looking at 2 into 2 into 2 into 2, 192 times, every 2 into 2 gives you a 4. So 2 raised to 192 can be written as 4 raised to 96. That is the first understanding we need. Exactly, Samia. That is the idea. So this is clear. 2 raised to 192 is same as 4 raised to 96. If it is not clear, we will discuss this concept in detail in the surds and exponents. I think it is the next chapter in our schedule. Check our schedule, next chapter or next to next chapter. So 2 raised to 192 is same as 4 raised to 96. Now 4 raised to 96, 4 have a property when you divide by 6. 4's powers. Look at this. 4 raised to 1 divided by 6. Remainder is 4. Na? I am only telling about the remainder, not about quotient or anything else. 4 raised to 2. 16 divided by 6. 16 by 6 remainder is again 4. Na? 12 by 6 remainder is 0. So 16 by 6 remainder is 4. 4 cube 64. 60 is a multiple of 4. 64 is a multiple of 4 plus 4. So remainder is again 4. 4 raised to 4. 4 raised to 4 is 256. 256 again. 252 is a multiple of 4. So multiple of 6. So 256 is 4 more than that. So for any power of 4, when you divide it by 6, the remainder will always be 4. If you want, you can learn it as a theorem. Otherwise, you can observe it like this. That means 4 raised to 96, the answer will be 4 only. Na? This is one way of doing it. The same question can be done in another way using surds and exponents chapter idea also. When we discuss surds and exponents, I will mention about it briefly. Did you understand this? Please respond. These are more examples to try. These are more examples to try. So just a minute. Is it clear? Please respond. You're going a little faster, but please respond. This is clear or not? Is it clear? Yes. So this question, please try. The explanation is given here. You can pause the video and check the explanation. Those of you are watching the recording, or when this recording is ready, you people can check it out live, students. And this is another question in 2023 which was asked. I will add this in our practice questions. Yesterday onwards, we have started the practice questions to be posted in our Telegram channel. Check the description of the video if you want to be part of our Telegram channel for UPSC CSAT, and for CSIR NET and GATE there is another Telegram channel also, so you can be part of it according to the exam that you are preparing for. So there I will post these questions so that you can practice these questions. Yesterday we discussed about LCM. Now this is a hybrid question where LCM and reminder both are involved. LCM and reminder both are involved. Please try this question. It is easily doable. Use the elimination by substitution method. The 15 methods we discussed in the previous classes, or in previous classes we mentioned about it. In previous videos in this channel we discussed about it already. There are 15 shortcut methods for general aptitude. Here elimination by substitution is the better method. In this question also elimination can be done. Try this. This is again a hybrid question. Surds and exponent idea can also be used. After learning surds and exponents, you will get a better idea of this question. Okay, I think let's conclude here. It's already 9:15. Is it clear, all of you? In limited time, I tried to complete as much area as possible. Please let me know whether it was useful. And once more, a gentle request to all of you. If you feel the series is useful for you, and if you feel this series is useful for your fellow aspirants, please try to share it with all of your friends or any Telegram groups or WhatsApp groups relevant for the UPSC preparation. You can share there also so that more people will get to know about this course. This is a course we are planning for 40 continuous days, Monday to Friday, every day at 8:30 p.m. So try to support this initiative by inviting more of your friends. And do let me know whether it is useful. Definitely you can tell your feedbacks whether it is positive or negative. Please tell your feedbacks. So the class is over. Those of you have doubts, smaller doubts, please ask. I'm not extending this lecture too much because, as I told, in 30 minutes is the tagline. So I don't want to make it more than 1 hour. But doubts, if it is some doubts which can be cleared faster, please ask it. Or check out the other resources we are adding along with this course. That itself will give you clarity on your doubts to an extent at least. So the practice question, we are planning for 10 practice question every day. So the 10 practice question on this topic will be posted either today night or tomorrow morning. You will be getting it in the Telegram channel. So check the description of the video for the Telegram channel. New students, and all of you, make sure that you subscribe this channel and hit the bell icon so that you will get notified whenever I go live or whenever there is any announcement in this channel. You will be getting notified. And my CSIR NET aspirants or CSIR NET students, the complete course for CSIR NET General Aptitude is available in the mobile application Christy's classes. 50 recorded videos in covering complete theory, previous year questions, and online study materials are available in this course. So check out the mobile application Christy classes for that. And free study materials also are available in the mobile application. And those of you want to purchase the UPSC CSAT flashcards or CSIR NET flashcards, you can check it out in our mobile application. These are the details of it. Currently, it is sold at an offer price. Those of you want to, you can check it out. Also, it is available in Kindle, Amazon Kindle also it is available. Those of you are using Kindle devices or Kindle app in your mobile. Flashcard revision and practice question is enough. For which exams of the students of other exams are also attending, that is why I'm asking for which exam. As I generally say always, it depends upon your level and your practice already you had. Depending on that, you have to seek more resources. If you are already good at aptitude and basic practice is enough, definitely this course and flashcards will be enough. Practice questions and this course and flashcards. But if your base is not that clear, I will suggest you attend a basic course also. For UPSC, yeah, to an extent. Now for the upcoming UPSC, following too much content won't be practical. So what I will suggest is stick on to this content itself, and practice question, make sure that you try all the practice questions. If you have already a good basic idea of UPSC CSAT, that is definitely enough. But for UPSC, I will suggest you comprehension also, please focus on that, because that is also very important. In this series, we haven't planned for comprehension, but do let me know if you want a comprehension series in this YouTube channel. We will plan for a series if time allows and if more people are interested. Comprehension, quant and reasoning together, you can easily clear UPSC CSAT. So if your base is already good, definitely the series will help you to practice and revise along with the practice questions. That will be enough. Okay, so I'm telling this because I don't know whether those who are putting the comments are the students who have attended my course already. Those who have attended the course already, definitely this YouTube live and practice question is more than enough for your final revision. But those of you haven't attended the course, I don't know your level already. Now, if you're already good at aptitude, definitely this will be enough for your final revision. So that's it. Thank you all of you. Take care all of you. Have a good night. See you all on the next class. Tomorrow 8:30 p.m. is the next class. Thank you. Take care. Bye bye. Have a good night.